Okay, we are going to do the last lesson of Chapter 6 today. I'm sorry I couldn't be there, but it should be okay. You should be fine with just a video. Just some reminders before we start. Make sure you turn in your homework from last class after you have checked your answers. This is the last lesson, so you have 2 more class periods to get anything turned in and to get ready for the test. I believe that is it. Okay, so combinations and permutations. This is 6.6 out of your textbook. There's not as much actual probability in this, but we will talk about some probability with it. Okay, so list all the possible combinations for a student answering a 2-question multiple choice test with 4 answer choices pictured below. I want you to pause the video and answer this question, and then come back and check. Okay, you should have paused and answered it. So we are just listing the sample space. So for this one, list all the possible combinations in this sample space. And I'm sorry, my handwriting is going to look rough. I am using a mouse. You could answer question 1 with an A and question 2 with an A. You could answer question 1 with an A, question 2 with a B. Question 1 with an A, question 2 with a C, question 1 with an A, question 2 with a D. Okay, we could also answer question 1 with a B, and then 2 with an A, or B, B. You should kind of get the hang of it now. B, C, B, D. Okay, we could do C, A, C, B, C, C, and C, D. Okay, and then we could do D, A, D, B, and D, C, D, D. So those are all the possible combinations. Now looking at this, I know that there are 16 total. Also, I'm sorry if you can hear my mouse. I feel like that would bother me. And so I want you to think, how could I get that number without actually listing them all out? And so looking at this problem, well, I could say 4 times 4, right? Because I have 4 choices. Oh man. For number 1 and 4 choices for number 2. So that's going to be something that we can use anytime we want to know how many combinations we can make with a bunch of different things. So that is called the fundamental principle of counting. If an operation can be performed in m ways and a second operation can be performed in n ways, then the total number of ways to perform the sequence of 2 operations is m times n. So anytime you want to figure out how many combinations you can make with this many of this, this many of this, this many of this, you are just going to multiply how many options there are. You do not have to remember the words fundamental principle of counting. Just remember that you can multiply how many are in each category to find the total combination. Alright, so we're going to do a couple examples of this. So the ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? So I know I can choose from 3 cone sizes. Okay. I can choose from 15 flavors. And I can only have 1 flavor, so I've only got 1 spot to put flavors. And 8 toppings. I've only can have one topping, so 8's only going to go in one spot. Okay, so 3 times 15 times 8. When we multiply those together, we get 360. So there are 360 possible combinations we can make at this ice cream shop. Second example, Nick's science test has a section with 12 true or false questions. How many different ways can Nick answer these questions? So we got to think each question is true or false. So first question, we have 2 possible options. Second question, we have 2 possible options. Third question, we have 2 possible options. And you should kind of see this pattern here. This is going to go on 12 times because there are 12 questions. So a way we can write this without writing out 2 times itself 12 times, you should be shouting it right now, is 2 to the 12th power. Okay, so 2 to the 12th power, we're going to simplify that. And you should get 4,096. If you don't already have a calculator with you, go ahead, pause the video and go get one. You're gonna need one for the future questions. Alright, so he could answer his test 4,096 different ways. Okay, Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? So 3 letters, we have 26 letters in our alphabet. Okay, so our first 3 spots are going to be 26 times 26 times 26. Okay, followed by 4 digits. So digits are 0 through 9, right? So we have 10 digits that we can choose from. So we're going to have 10 4 times for those 4 digits. If we wanted to rewrite this with exponents, we could say 26 to the 3rd power times 10 to the 4th power. But either way, when we solve this, you'll have to pardon me, I have to use my calculator. 26 to the 3rd power, we get 17,576 times 10 to the 4th power, that's going to be 4 zeros. We're going to get 175,760,000. So there are 175,760,000 possible license plates. Okay, the next thing that we're going to talk about is called factorial. If n is a natural number, the notation n exclamation point is called n factorial and is the product of all the natural numbers from n down to 1. So if you see n factorial, you're just going to take n times the number before it, times the number before it, times the number before it, until you get down to 1. So 4 factorial, we're going to take 4 times all the numbers before it. So times 3 times 2 times 1. Okay, so 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. Okay, so anytime you see 4 exclamation point, that's 4 factorial, and you're doing 4 times 3 times 2 times 1. All right, so our example here, 6 factorial over 4 factorial. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial, so 4 times 3 times 2 times 1. Now, I know that this looks like, okay, I'm going to multiply everything on the top, everything on the bottom, then divide. Make your life a little easier. If it repeats in the top and the bottom, since we're working with products, we can cancel out repeats. So 4 cancels, 3 cancels, 2 cancels, and 1 cancels. So we're really only doing 6 times 5, which equals 30. So on the next one, we're actually going to shorten it a little bit. 11 factorial over 9 factorial. I know that 11, once I hit 9, everything after it's going to cancel, right? So I'm going to write this out. I'm going to say 11 times 10, and I'm going to stop at 9, and I'm going to say 9 factorial, because this 9 factorial on the bottom is going to cancel out all of those numbers. So I'm just doing 11 times 10 here, and I'm going to get 110. All right, next example, 72 factorial over 70 factorial. So these problems are the ones that are the reason we learn that we can cancel out, right? Because you don't want to write 72 times 71 times 70 times 69 times 68 times 67. That would take forever. So really, I know 72 times 71 times 70, I'm going to stop because that's what I have on the bottom. So 70 factorial over that 70 factorial on the bottom is going to cancel that out. So now I just need to find 72 times 71. Okay, so I'm typing in my calculator 72 times 71, and we get 5,112. All right, last basic factorial question. How many ways can you arrange the letters in the word dinosaur? So dinosaur, we have 1, 2, 3, 4, 5, 6, 7, 8 spots. So I'm going to draw out 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then none of my letters repeat, so I have 8 individual letters. So I start my first letter, I have 8 to choose from. Okay, my second letter, I have 7 to choose from because I've taken 1 away. Third letter, I have 6 to choose from, and it's going to keep going down until I hit the last spot. Times 3, times 2, times 1. Okay, so 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 are how many ways I can arrange these letters. That is also just known as 8 factorial, right? So 8 factorial, we're going to multiply these out. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 40,320. So that's how many ways you could rearrange the letters in the word dinosaur. Okay, so those are your factorial questions. You need to know how to use factorial because I'm about to show you a formula that uses factorials in it. Now, the first one we're going to look at is called the permutation. Now, this is an ordered arrangement of items in which no item is used more than once, so no repeats, and the order of the arrangements makes a difference. So I want you to make a note at the top of your notes. And just draw an arrow up from permutation. Oh, let me erase that. And I want you to say use, we can just say P, when order matters. So these are things like you are ordering people first, second, and third place, or You're the president, the vice president, and the secretary. Or you're ordering things like a class schedule. So these are things where order matters. Okay, now you have a formula for this. This is on your formula sheet. Now you need to write it on your notes because I did not give it to you, I just gave you the box. So permutation, you know, anytime you want to find an ordered arrangement when the order matters, you're going to use a permutation. And so that's going to be n factorial over n minus r factorial. Now, n is your total number of objects available, so how many people are you counting from, how many classes are you using on your schedule, and then r is how many to use for the arrangement. So are you making a group of 3 leaders? Are you putting 4 classes down on your schedule? Okay, so we're going to do some examples. 7 students are competing in a geography B. How many ways can they finish in first, second, and third place? So I want you to underline this part right here. First, second, and third place. Which, I'm sorry, my underlining looks rough. Please don't underline yours that bad. Because they're getting a placement, order matters, so I know I'm using P. Okay, so I need to identify N and R. Okay, so N is how many total, right? So there are 7 students competing, so N is going to be 7. Okay, R is how many we're arranging, so we have first, second, and third place, so that's 3 spots we can use. Okay, so 7, P, 3. So looking at our formula that we just wrote, you are looking at it, I don't have it on my screen, but I know it. We have n factorial, right? So we're going to have 7 factorial over n minus r. So 7 minus 3 factorial. All right, so 7 factorial over 7 minus 3 is 4 factorial. Okay, so I'm going to write this 7 out until I hit 4 factorial, because I know it's just going to cancel that out on the bottom. So 7 times 6 times 5 is 210. So there are 210 ways that 7 students could finish in first, second, and third place. Okay, our next example, Melanie is taking 4 classes this semester: American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged on her schedule? So because I'm talking about a schedule, I know the order matters. So my N and my R, I have American History, Algebra 2, AP English, and Chemistry. So I have 4 total classes I'm using. And then we're arranging them on a schedule, so she has to take all 4, right? Okay, so I'm using 4, P, 4. So using our formula, we have 4 factorial over 4 minus 4 factorial. All right, so we simplify. 4 factorial over 4 minus 4 is 0. Okay, now you might want to make a note. 0 factorial, I know when you see 0 anything, you want to just assume it's 0. 0 factorial is 1. Okay, so this is actually just 4 factorial over 1. So 4 times 3 times 2 times 1 over 1, which we don't have to write over 1. So we already did 4 factorial, right? That's 24. So she has 24 ways she could arrange her classes. All right, moving on. There are 16 players on the baseball team. How many ways can the coach make a 9-player batting order? Okay, so batting order, this is where my non-sports people might have a harder time. In baseball, the batting order does matter. It matters which way you line them up, who's going to go first, who's going to go second, all of that. It's really the one sport where the order of the players matter. So we know we're using permutation, so we're going to find N and R. There are 16 players on the team, and our batting order is 9 players. So N is 16, R is 9. So we have 16P 9. Alright, so we're going to have 16 factorial over 16 minus 9 factorial. So simplify. 16 minus 9 is 7. And then that means I'm going to pull out the 16 factorial till I hit 7. So 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7. And that 7 factorial is going to cancel out. Okay, so in my calculator, I'm going to type all that out. And I am going to get 4,151,347,200. Now I would be super impressed if any baseball coach wrote out this many batting orders. But they're never going to run out. Okay, so those are permutations. Those are when order matters. Our other thing that we can make is a combination. So I want you to draw a little arrow out from this. You are going to use combination, or C, when order does not matter. So these are your things. You're just picking 3 people to go be on a group. You're picking 4 people to help you with a project. You're picking 5 candy bars to buy. It doesn't matter what order you pick these in. Now this formula is similar but a little different. You should notice that it still has your N and your N minus R, but now it has this part right here that's not going to cancel out. So you might want to make a note when you write this formula that now you have a bottom, a denominator that does not cancel. Okay, but N and R still stand for the same things. And by the way, both of these formulas are on your formula sheet. You don't have to memorize either one. Okay, so let's look at some examples of these. There are 12 employees at the sub shop. How many ways can the manager choose for the Sunday evening shift? So because we're talking about just picking 4 to work a shift, we know it's C, combination. Okay, we still have to identify our N and our R. So N is our total, there are 12. And then R is how many we're arranging, so we can pick 4 for this shift. So now we have 12C4 instead of P. And so we have 12 factorial over 12 minus 4 factorial, but now we also have R factorial, so 4 factorial. Okay, we're still going to simplify, so 12 factorial over 8 factorial, 4 factorial. We're still going to pull out our top until we can cancel it with the bottom. So 12 all the way down to 8. 12, 11, 10, 9, 8. Okay? So that's going to cancel out 8 factorial. I'm going to go ahead and cancel those out. But now this 4 factorial right here is not gone. So we have to write out 4 times 3 times 2 times 1 on the bottom. Okay, so in the top we have 12 times 11 times 10 times 9. So 11,880 over 4 times 3 times 2 times 1 we already found was 24. Okay, so let's go ahead and divide 11,880 divided by 24. And we're going to get 495. Okay, so a little different, maybe one extra step really, but again, you have your formula on your formula sheet. You just need to remember, does the order matter? If so, it's a permutation. If not, it's a combination. And then what your N and your R stand for. Okay, let's do another. There are 85 players on the football team. How many ways can the coach choose 3 to represent the team in the coin toss? So order doesn't matter. He's just picking 3 to go out there. N is our total, 85. And R is how many we're choosing. So we're choosing 3. Okay, so 85 C3. Using our formula, we'll have 85 factorial over 85 minus 3 factorial, and then 3 factorial. Okay, so we simplify. 85 factorial over 82 factorial, 3 factorial. So we're going to draw out our 85 until we hit 82. 85 times 84 times 83 times 82 factorial. Okay, over 82 factorial. Those cancel. And then 3 factorial is 3 times 2 times 1. Now, right away, 3 times 2 times 1 I know is 6. But I do not know the top. So 85 times 84 times 83 in my calculator is 592,620. Okay, if I divide that by 6, I'm going to get 98,770. Again, I would be super impressed if our football coaches made 98,770 combinations. But they could if they wanted to. Okay, there are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? So, attending birthday party, your order doesn't matter. They're all going to the same party. So N is 24. And then he has to choose 8, so R is 8. Okay, so we have 24 C 8. Okay, so in our formula we'll get 24 factorial over 24 minus 8 factorial, 8 factorial. Okay, so we simplify. 24 factorial over, that'll be 16 factorial, 8 factorial. So we pull this out to 16. So 24, 23, 22, 21, 20, 19, 18, 17, 16 factorial over 16 factorial. Let's go ahead and cancel those. And then this 8 factorial we're going to write out. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now when you type this top in your calculator, it's a really large number, so it's going to give you scientific notation. A way around this is we can type in this whole thing if we put parentheses around our numerator and our denominator. So we're going to type it parentheses 24 times 23 times 22 times 21 times 20 times 19 times 18 times 17. Close your parentheses, divided by, open a new set of parentheses, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and then close your parentheses again. Okay, so type that in. typing it in right along with you. Okay, and we should get the answer, 735,471. Okay, so those are all our specific combination examples. Now I want to look at probability using combinations and permutations right quick. So our example, a group consists of 6 men and 5 women. 3 people are selected to attend a conference. Okay, part A, find the number of different groups of 3 people to attend the conference. So finding a group of people to attend a conference, order is not mattering, so we're going to use C. And we just have to identify our N and our R. So total, we have 6 men and 5 women, so that's 11. And then 3 are attending the conference, so R is 3. So we're going to find 11C3. Okay, so that's 11 factorial over 11 minus 3 factorial, and then 3 factorial. Okay, so we have 11 factorial over 8 factorial, 3 factorial. So I can write out 11 till I hit 8 factorial, and then those will cancel. But then I also have 3 times 2 times 1 in the denominator. Okay, so 11 times 10 times 9. We'll go ahead and use those parentheses, get those done in one step. Over parentheses 3 times 2 times 1. And you should get 165. Okay, so 165 different groups could attend, or different groups of 3 could possibly attend. Alright, part B, find the number of different groups of 3 women to attend the conference. So now in our total, we're just looking at women, so N will be 5. So it's still going to be 5C3, not still, but now 5C3. So 5 factorial over 5 minus 3 factorial, 3 factorial. So simplify, 5 factorial over 2 factorial, 3 factorial. Now some of my classes yesterday were saying, well, now the bigger number is the second one. Can we cancel that one out? It doesn't matter which one you choose. Usually the bigger one would be less things, but really these are right next to each other, so it doesn't matter. I found that more people preferred to just stick with the first number, so we'll do that. So 5 all the way down to 2. And that's going to cancel out with this 2 factorial. But then 3 factorial is 3 times 2 times 1. Now here's where it like adds in a step really. That 3 cancels, so we don't have to leave those 3's there. Now this one you should be able to do in your head. 5 times 4, 20. 2 times 1 is 2. 20 divided by 2 is 10. Alright, part C. Find the probability that the selected group will consist of all women. So probability of all women. Now probability, remember that's our fraction. We're taking how many we want, so how many groups of all women, over total, so how many total groups could we make? So thinking about what we just did, we found that we can make 10 groups of all women. And we found that when looking at everybody in the group, we could make 165 groups. And then we simplify this. So we can divide both of these numbers by 5. And we will get 2 over 33. Now, let me preface this, or I guess not preface because we're done with the problem, but on your homework and your test, it will be broken up into parts. But when you take the EOC, what they're going to do is they're going to give you just this question, part C. You have to know that you have to find the number of all women groups and the total number of groups using combinations. When you take the EOC, which we will get to more towards review time, but just be aware that that is something that will happen, will show up on those tests. All right, coming up on our last example, we've got a fast food restaurant that has a meal special, $5 for a drink, sandwich, side item, and dessert. The choices are in your table. Notice this is not a choice, it is just the label. And also, these are flip-flopped. So, part A. Find the number of different meal specials if you choose one sandwich, one side item, one drink, and one dessert. So no specifications, we can use any sandwich, side item, drink, and dessert. Now this one, you should be able to identify, oh, this has got like different categories. This is not asking you to arrange like a big group into 3. This is saying sandwiches, side items, drinks, desserts. I am going to use the fundamental principle of counting. I'm just going to multiply. So we're going to take sandwich. So we have 4 sandwich options times sides. We have 3 side options times drink. We have 5 drink options times dessert. And we have 2 dessert options. Okay, so 4 times 3 is 12, 5 times 2 is 10, 12 times 10 is 120. Okay, so that's part A. Part B, find the number of different meal specials that you will choose both chicken and soda. So now we are kind of like limiting our options here. So our sandwich, we are only looking at chicken sandwiches. So there is only one option that has chicken. Our sides, we can do any side. So sides are still 3. Our drinks, we're only looking at sodas. So that's only going to be 4 of our drink options. We're not going to include tea. And if you want to write, I probably should have written soda instead of drink. And then our desserts. And we don't have any limitation on desserts, so that's still 2. Alright, 1 times 3 is 3, times 4 is 12, times 2 is 24. I don't know why I drew a line. So there are 24 options to get chicken and soda. And then finally, just like the last one, what is the probability that the meal will include both chicken and soda? So probability that we will get chicken and soda is going to be how many meals with chicken and soda can we make over how many total meals can we make. So again, looking at those answers we just got, we found that we can make 24 chicken and soda meals, and we can make 120 with all of the options. Okay, so we simplify that. We can divide both those numbers by 24, and we're going to get 1 over 5. Alright, so that is the lesson over combinations and permutations. Your homework is due next class. You may work in groups. If the sub feels like you're not behaving and they move you out of the groups, then don't complain. But work on that. It's due next class. If you have any questions at all, I have Remind. If you've joined Remind, you can text me there, or you can use Google Classroom and I will see it if it notifies me, or I'll be checking throughout the day. Thanks for watching.